Hi folks, we're going to take a look at page 106, number 9L. So we have this limit here. So I notice right off that the denominator of that first expression approaches 0, so we do have an issue to contend with. So if we check the other part of the function, we've got the left side here approaching 1 over 4, and the right side approaching 2 over 3 plus 5, 8. So which again, 1 over 4. So 1 over 4 minus 1 over 4 is 0 over this denominator approaching 0, so we have an indeterminate form, which means that this limit may or may not exist. Okay, so we're going to do what we always do in this case, which is see where the algebra takes us, see if we can rewrite this expression in a form where we can actually take the limit. So let's do that. So can't really do much with that first term for now, so let's leave it out, and let's now subtract these expressions. Okay, so here we'll have a common denominator of x plus 3 and 3x plus 5. Okay, now you'll notice here I'm going to make use of brackets to try to avoid any sign errors. So here in this first expression we're missing the factor of 3x plus 5, so we have 1 times 3x plus 5 up top here, and then minus 2 times, and we're missing the factor of x plus 3. So x plus 3, and so now let's keep going in our simplification. So 1 over x minus 1, and then here let's see what we have. We have 3x minus 2x is x. Then here we have 5 minus 2 times 3, 6. So 5 minus 6 is negative 1, and that looks quite helpful. Okay, and so here we see that we can reduce this x minus 1 in the numerator and denominator, and we are indeed left with an expression for which we can evaluate the limit easily. So we're left with 1 over x plus 3 times 3x plus 5. Okay, and this function here does have a limit. In fact, it's continuous at x equals 1, hence we know that the limit will just be equal to the function value. Okay, so now that we're evaluating the limit, we're actually seeing what this is going to be approaching. We don't write the limit notation anymore. So we're going to evaluate this at the function value since it's continuous at 1. So we've got 1 plus 3 times 3 times 1 plus 5. And so here we have 1 over 4, and then 3 plus 5 is 8. So 4 times 8 is 32. Okay, and there we have it. So let's just to quickly recap. We had a scenario where this was indeed an indeterminate form, and so we just used the algebra at hand in order to simplify it and reduce it to an expression which is not defined at 1, but has a limit at 1. Okay, that's it for now.